We are now talking about solution concentrations. There are two ways to express the concentration, which is the ratio of solute to solvent in a solution. They are molarity and molality. You'll find on Edmodo this worksheet, molarity and molality, concentration of solution. To begin, we want to make sure that we know the formulas for each, since they're expressed a little differently. Molarity is the ratio of moles of solute for every liter of solvent. Therefore, the unit for molarity, capital M, is the same thing as mole per liter, which can be used as a conversion factor. Whereas molality is the ratio of mole of solute per kilogram of solvent. Sometimes we'll have to convert from liters to grams in these problems. And therefore, the unit of small m, lowercase m, for molality is equivalent to moles per kilogram. Again, this can be used as a conversion factor. Your job now is to memorize this. Let's look at some of the practice problems. The heading reads, Calculate molarity, big M, referred to as concentration. Example, we made a 5.5 molar solution of NaCl. In question 1, they ask, what is the molarity of the hydrochloric acid solution when 3.5 moles are dissolved to make 4 liters of solution? Let's look at how to work one of these. Start by identifying your given information. Then identify the question. It's not necessary for you to write this out the way I have, but I am trying to demonstrate that they have told us now the moles of solute, 3.5 moles, and the volume in liters of the solvent, 4 liters. And we need to find the molarity. So we do have to write the equation, substitute in and solve to the correct number of significant digits. The calculator says that 3.5 divided by 4 is 0.875. Since our units in the problem were moles per liter, that is molarity, capital M. Since 3.5 and 4.0 both have 2 significant digits, we're going to round our 0.875 down to 2 significant digits. That means the digit 8 and the digit 7. Since the digit to the right of the 7 is a 5, that rounds the 7 up. So we express it as 2 significant digits by 0.88 capital M, which means moles per liter. And that's how we solve a molarity problem. If another unit is given, there will be some conversion necessary. For example, if our solute was given in grams, for example, for hydrochloric acid, if they had told us that we had 80 grams of hydrochloric acid, we would then need to do a little bit of stoichiometry and convert and see how many moles is that. We would have to look up the mass of hydrogen and the mass of chlorine and add those together. Since the molar mass of hydrochloric acid adds up to 36.46 grams, if we had 80 grams of hydrochloric acid, we have almost 3 moles worth. Let's do the math. Well, 2.2 moles at least. So in a problem that gave us grams, we would have to first convert to moles by using the molar mass. If the volume of the solvent was given to us, say, in milliliters, we would have to convert that first to liters. And for every liter, there are 1,000 milliliters. So whatever volume they gave us, we would have to divide by 1,000 to convert it to liters. The problem doesn't work unless solute is expressed in moles and solvent is expressed in liters. All right, after you've completed that first page and you go to the next, you'll notice that we're now calculating for molality. Here, they're indicating that we just might have to convert grams to milliliters and maybe even kilograms to liters. There might be some conversion involved, so you need to watch that. Number 1 says, what is the molality of a sodium chloride solution if 2.1 moles of the salt, sodium chloride is a salt, are dissolved in 4 kilograms of water. We're going to set this up much like we did the last, only we're going to use molality instead of molarity. First, I'm going to write down the given information. The problem states that we have 2.1 moles of our solute, the NaCl, and we have 4 kilograms of the solvent, which is the water we're going to dissolve the salt into, and we need to find its concentration as molality, which is the ratio of moles of solute per kilogram of solvent. Let's substitute in and solve. The calculator says that 2.1 divided by 4 is 0.525. Our given information were both expressed as 2 significant digits. So we need to round our answer down to 2 significant digits. So we'll need the 5 and the 2. And like last time, this 5 is going to round the 2 up so that our expression for concentration is going to be 0.53 lowercase m. It's 0.53 molality. Let me scoot that up. Now, if we want to talk about how we're going to convert the solvent, if necessary, if given milliliters, we already know how to convert that to liters, and we also know how to convert it to grams, because whatever it is in milliliters, that's what it is in grams. And to convert grams to kilograms, we know that every 1 kilogram has 1,000 grams. Or we can convert milliliters to liters, because every liter has 1,000 milliliters. And then according to what it says up top, for every kilogram, that's going to equal a liter. There is a proportional relationship between the equilibrium of milliliters to grams and kilograms to liters by a factor of 1,000. It would be best if you just memorized this. You're going to finish the remainder of those practice problems. Now that you know how to express concentration as molarity and as molality, in our next lesson we will use these to solve some stoichiometry problems for chemistry. Have a good day.